Welcome to day 4 of our daily fraction. Let's go ahead and shade in our next day. We're going to put that back in. And then our beginning fraction. Well, our denominator is always the total amount of school days. We have 180 school days. And we are on day 4. That's our numerator. Okay, and now we're going to find all our factors for the number 4. Okay, we always find the factors for our numerator. 2 factors we always know are 1 and the number itself. So 1 times 4, and then the commutative property multiplication, 4 times 1. So thinking of just the whole numbers between 1 and 4, that would be 2 and 3. So we just have to see if 2 or 3 is a factor. 2 is 2 times 2 equals 4. But 3 times another whole number doesn't equal 4. Whenever you have factors that are exactly the same, we call that a perfect square. And I'll show you why in just a little bit. So now there's no whole number between 2 and 2, so we are done. Let's list our factors from least to greatest. We have 1, 2, and 4. So 1, 2, and 4. We have 1, 2, 3 factors. Since we have 3 factors, that is more than 2 factors. Prime is exactly 2 factors. Composite is more than 2 factors, so it is composite. Okay, we're going to start with our greatest factor, which is 4, to see if it's our greatest common. If that doesn't work, then we'll go to 2 and then to 1. But we want to start with our largest one, because if that one works, then we're good to go. Okay, so let's make groups of 4. Remember, when you're making your groups of 4, you're shaded in a group, or your shaded blocks all together in your groups. You don't want to have part shaded and part unshaded. But this is why it's called a perfect square, because you have a 2 by 2, it makes an actual square perfectly. So our perfect square numbers, when they have the same factors, end up making perfect squares. Okay, so remember, you can make your groups any way you want. You could make perfect squares. You could make them all columns or all rows. You can even make it like an L shape. You could do the perfect square. As long as there's 4 in each group, that's what's the most important thing. So make sure there's 4 in each group, and you do not have the shaded with the unshaded. So here we're actually doing division. We're just doing it in a model. And we want to see, are there any squares not in a group of 4? No, there's none left over, so there's no remainder. That means 4 is a factor of both. It is the greatest common factor. So let's count up the total amount of groups. That's our new denominator. So let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 28, 29, 30, 31, 32, 33, 34, 35, 36, 41, 42, 43, 44, 45. 45 total groups. And how many groups of 4 are shaded in? There's only 1 group of 4 shaded in. Okay, so that, based on our model, is our equivalent fraction in lowest terms, or our simplest form. But we do also want to prove it a different way. The more ways we can do it, different ways, and get the same answer, we can be pretty certain of our result. So we're going to divide both of them by our greatest common factor, because we put the shaded into groups of 4 and the unshaded. Okay, so first, 180 divided by 4. Well, something that I know and you'll want to make sure that you're aware of is that 4 quarters is $1. 4 times 25 gives us 100 cents, or $1. So I can do 4 times 25 to get 100. Okay. Numbers the same, zeros the game, more on top, no need to stop. Numbers the same, zeros the game. I think I know what to do to get here, but I'm not sure. So I'll multiply by a number I am sure I can multiply by. So 10 times 4 is 40. Numbers the same, zeros the game, more on top, no need to stop. Oh, and again, 10 times 4 is 40. Numbers the same, zeros a game. So I have a remainder of 0. Now I need to add up my partial quotients. 5 plus 0 plus 0. 2, 3, 4. I did get 45, but I want to check using my inverse operation. My divisor times my quotient plus my remainder. Now, since my remainder is 0 and the identity property of addition says when you add 0 it stays the same, I don't really need to add the 0. So I'm going to just do the divisor times the quotient. 4 times 5 is 20. 4 times 4 is 16 plus 2 is 18. That checks. Okay, and now 4 divided by 4. Well, 4 times 1 is 4. Numbers the same, zeros a game. So our quotient is 1. Now we check divisor times quotient plus remainder, but our remainder is still 0, so that identity property of addition, it'll stay the same. And this is actually the identity property of multiplication. When you multiply by 1, it stays the same. 4 times 1 is 4. Check. So our numerator is definitely 1 and our denominator is definitely 45. We proved it 2 different ways. All right, let's go ahead and fill in our data collection page. We are still in trimester 1, week 2. Today is 8/13/19, and our fraction for today is 1/45. Let's go ahead and get out our number line. Okay, we did groups of 4. So let's go over to that first line. We have 1/45, and it needs to be right under the line because that represents that one piece right there. If you look, it lines up with the line here, so we have an equivalent fraction here that we haven't written down yet, and 4/180ths. Those are all equivalent fractions. Okay, let's go ahead and put your number line away. Erase your worksheet, and thank you for joining me.